We're going to find the empirical formula and the molecular formula given the percent composition. So what do we do first? We're going to assume that we're going to consider that we have 100 grams of this compound. So if we have 100 grams of the compound, we can turn these percentages to grams. So if we had 100 grams of this compound, we would have 58.8 grams of carbon. And that's 58.8%. All right, and what? Oh, okay, these commas got me a little confused. Wait, no, yeah, all right. So hydrogen, if we had 100 grams, hydrogen would make up 9.8 grams of this compound, and oxygen would make up 31.4 grams of this compound. So that's step one, turn the percentages into grams, and if we assume that there's 100 grams of it, we can simply switch the percentages to grams. All right, step two is to get the moles of each of these, and since we're trying to get the formula, this is not an analytical calculation. We can just use, we don't have to write all these digits, like 12 is fine for carbon, 12.0, let's just go with that. So molar mass is used to convert grams between grams and moles. So, right, 1 mole of carbon has 12 grams. Let's punch those numbers in. 58.8 divided by 12 is 4.9 moles of carbon. Okay, and hydrogen is 1 mole of hydrogen is 1.01. Let's go with that. Grams of hydrogen. All right, that's going to cancel out. 9.8 divided by 1.01 is 9.7 moles of hydrogen. And finally, 1 mole of oxygen has a mass of 16 grams. So we did that to cancel out the grams and convert that to moles. So 31.4 divided by 16 is 1.9. No, that's just 2 moles of oxygen. Okay, so our next step is to determine which one is the smallest number, and let me check my calculations again. Okay, so 2 is definitely the smallest. So let's see how many times 2 moles goes into all the other moles. All right, and so I'm just going to use 5. 5 divided by 2 is 2.5 moles there. And then I'm just going to use 10. All right, 10 divided by 2 is 5. And then 2 in itself is 1. All right, shucks, we have fractions. All right, so right now we have our empirical formula as C 2.5 H5 O1. Okay, so this is a problem. We need to multiply through by 2, right, to get rid of that fraction. Okay, so let's multiply that by, hold on, I've already used this color. Let me pick a different one. That's maroon. All right, let's multiply through by 2. And so we will have the empirical formula as C5H10O2, and that's the lowest whole number ratio. There's your empirical formula. Empirical. Okay, so we've answered this. Now we're going to figure out the, I'm running out of colors. All right, let's use purple. All right, now we need to calculate the molecular formula, and so we're just going to see how many times the mass of the empirical formula goes into this molar mass. So I'm going to need a little more room. All right, molar mass is 102. 102. 102. Okay, so molar mass. That's the mass of this unknown compound. So 102. And so the the empirical mass. Okay, so that's over here. We need to get that mass. So carbon is 12 times 5. All right, let's say it's 60. And then hydrogen is 1 times 10, and that's 10. And oxygen is 16 times 2, and that's 32. All right, so let's just roughly see what the molar mass of this empirical formula is. This empirical, right? So 60 plus 10 is 70, plus that's 102. Okay, so oh, look at that, 102. All right, so the molar mass is the empirical formula is the molar mass, and the slow down, slow down. All right, the molecular formula, molecular formula is the same as the empirical formula. So C5H10O2. So that is our answer to both empirical and molecular formulas.